Hey what's up guys, my name is Cherno. Welcome back to my C++ application architecture mini-series. This is the second video in the series. I'll have the first one linked up there. Make sure that you watch it first. Today we're going to be talking all about layers. So once you have this sort of basic architecture down, the next thing you're probably going to want to do is somehow create this like user code app specific part of your application. You have a core library that does all of the behind the scenes work to actually make a computer application work. But now you'd like to get to the custom stuff. Why are you making this specific app? What is its purpose? What does it need to do? Now, fundamentally, applications, of course, have varying complexities and duties, we'll say, of what they are required to do. So of course, hypothetically, there might be an application that you're making that is so simple that it doesn't really need all of this over engineering, all of this abstraction, all of this, well, quite frankly, layer stuff that we're going to be talking about today. However, in practice, it's likely that your application will probably have various different states, and layers are one of the potential solutions to handle this kind of state system. A really simple example of this might be you're building a game. It might have a main menu with a play button that then plays the game. The menu and the game are two fundamentally very different states of your application. They need to do different things. A menu probably has a bunch of buttons that you can click. You might have like an options or a settings screen or a load menu screen. The way that you navigate the menu using your input devices, all of that is going to be fundamentally quite different to when you're actually playing the game, most likely. Because aside from, say, the rendering and the logic that you're updating every frame being completely different, even the way that the mouse or the keyboard works is also going to be so different. And so, logically, it becomes quite advantageous to separate those two concepts of your application out, because honestly, they may as well be two completely different separate applications. One might be a 2D UI menu and the other a 3D game world, but they both have to exist within this one application you're building. And that is exactly why this whole layer system exists, as a way to provide a solution to this problem. Now, a quick disclaimer, layers and layer systems can be as complicated as you really want. I'm going to start things off relatively simply. However, I have planned like an advanced layer video in this mini series, so let me know in the comment section below if you want to see that. But just know that things here with layers can get a lot deeper than what I'm going to show you in this video. So layers are typically made up of at least these things here, a way to actually create and destroy the layer. This is important because we may not want to keep the entire layer in memory all the time. We need a way to obviously create all of, say, the assets used for our menu, such as all the buttons, all the textures, and whatever else we might have. But then when we start playing the game, we might want to destroy it and unload those assets. So that would be an example of what we could do in the constructor and destructor, or alternatively separate functions like onAttach, onDetach, which some systems might use. OnEvent, onUpdate, and onRender, these three are kind of the meat of our custom functionality for that given part of the application. Events we are going to talk about in a later video, probably in the next video in this series, but that refers to basically all of our application events, whether that be a mouse button being pressed or a key being pressed, but also things like, was the window resized? We might want to respond to that. OnUpdate is like the logic part of what our layer is doing. So if we have a menu layer, that might be the part that actually checks to see, you know, what button we're hovering over. And if so, it might highlight it. It might respond to us clicking on it. A lot of that stuff can also be done within the event system, but of course it's going to differ based on your implementation. And finally, onRender is where you're going to be doing all the rendering. So you might be submitting some sort of geometry to be rendered by the renderer, stuff like that. Now, transition and suspend are basically two functions that you might use to change the state of the application by transitioning to a new layer or suspending the current layer and then transitioning. We're going to probably talk about suspending in the advanced video, but basically the difference is that suspend will keep the current layer alive and then transition to another layer, whereas transition will destroy this current layer and then transition. So you might want to keep it alive for whatever reason, not release the resources allocated there, and not have to create a brand new instance of that layer if you transition back to it. And that is what suspend is for. So these actual layers exist within something called a layer stack. And the reason why it's described as a stack is because you can kind of picture them as all of the layers you have stacked on top of each other in Photoshop. A layer on top of another layer is going to be rendered on top of that layer or after that layer. But then conversely, when you click on something, that event will usually propagate from the top of the stack down, because you're kind of clicking on the topmost layer, if that makes sense. Anyway, it doesn't have to be implemented as an actual stack data structure. I usually just implement this as a vector, but the ordering of these layers does matter. And so visually describing it as a stack makes more sense. So this layer stack will exist within our application class. The layer stack may be just a simple vector of all of these layer instances, but it could be an entire class, an entire custom data structure with lots and lots of functionality. It just depends on your needs. The initial example that I gave just had one layer being used at a time. So we had the menu layer, then we hit the play button, it would transition to the game layer. We've just got one layer active at once. But because it is a stack, you can have as many layers as you want simultaneously active. So for example, we might have this overlay sitting on top of all of the other layers in our entire application. So it doesn't matter if the menu is being shown or if the game is being played, we'll still have this functionality active. And that doesn't necessarily imply rendering, because layers don't have to do all of these things. They don't have to render anything, but maybe we just have something running globally throughout our application and we want that logic to function regardless of whether our menu layer or game layer is currently active. To show you a quick example of this, inside our application project, I've added this overlay layer, which sits on top of our app layer, which from the last video was rendering this flame over here. The overlay layer has this switch button functionality. If I click that button, what it will do is transition from that app layer, which was rendering this flame, to this other layer, which I've called void layer, which just displays a red clear color. So what's happening is that base layer is actually changing every time I hit the switch button, but the switch button is not changing at all, because it's part of a separate layer, our overlay layer, that is running the functionality to do with this specific thing. So hopefully that gives you a good example of how layers can sort of extend beyond just this simple one layer active at a time, transitioning from here to there. You can really control like the lifetime of layer functionality to be whatever you need it to be. And that's where multiple layers stacked on top of each other can really become quite useful. A real world example of an overlay that exists above all layers might be a debug layer. This might contain various UIs which describe what is going on with the application, what's even going on with the layer stack, what layer is currently active, give you buttons to control things and transition to different layers. It might be something that you strip entirely from distribution builds, but for development, it can be very, very useful. Now we're going to dive in and have a look at the code to see how all of this actually practically works, but hopefully this gives you an idea of how this can really keep your application and all of your code very, very organized. Exactly how Akiflow, the sponsor of this video, helps you keep your life organized. Optimizing your time management really seems to be one of life's most difficult tasks, and Akiflow can really help with that. Akiflow is a really well executed productivity and time management tool built to help busy people make the most of their time. You just take note of whatever you need to get done into your inbox, and then later go through the process of blocking out those tasks somewhere in your schedule. Akiflow's AI features can help make this more efficient by categorizing tasks for you automatically, and it does work quite well. Like for example here, it literally knows I'm talking about Hazel just from write some docs. Akiflow also integrates with tools such as Gmail, Slack, GitHub, and Jira to add tasks to your inbox automatically, so you don't miss anything. When I'm working and suddenly realize that I really need to get something done, I often don't write it down because I just don't want to break focus with what I'm doing. Akiflow has this really cool feature called the command bar, which lets you use a global shortcut anywhere on your computer to bring up this bar where you can write down what you need to get done. And it'll go straight to your inbox or even into your calendar if you write a time. This is one of my favorite features because it literally means that I'll forget less. Rituals are another cool feature which let you reflect on how your day went and plan your next day with daily plannings and daily shutdowns. So check out Akiflow today using my link in the description below, and you can even get an exclusive one-on-one onboarding call where someone from Akiflow will help you take control of your time. Huge thank you to Akiflow for sponsoring this video. So let's first talk about the user-facing side of the code. This is our client side. This is the app part of our core app architecture. This over here is where we implement our custom functionality for this specific app. What does that look like? Well, you can see over here in the main function, it still looks relatively simple. This is the one addition we have. We're pushing on an app layer and an overlay layer, whereas last time we just had this app layer. So we have multiple layers now that are active at the same time. You can see from the API point of view, it's really simple. We just have a layer that contains some custom functionality. Now, we already looked at app layer last time. The only difference is that we now have a way to actually transition to a different layer. So aside from that button, that switch button that we have on screen, I've also made the 1 key on the keyboard transition to this other layer, which I've called void layer. So if we have a look at what that looks like, aside from pressing the switch button, I can also press the 1 and 2 key to switch layers. And that is because the void layer inside its on update, if key 2 is pressed, then we transition to app layer. So this is to demonstrate transitioning the current layer to something else from within itself, as well as externally via the overlay layer. So again, really simple case here with the void layer. It's just got that red clear color. That's all it does on rendering. And the only logic it has is the ability to transition itself to the app layer, which renders the flame, by pressing the 2 key. And I've left this as raw as possible. We have just OpenGL here and GLFW being used directly because I'm trying not to abstract things. I'm trying to give you a raw look at what the code is actually doing. So back in main, we also have this overlay layer that doesn't get transitioned to anything else. It's the layer that sits on top of both our app layer and void layer whilst they do the transitioning, and that's what displays that switch button. So again, we have all of the custom functionality implemented here. This time we're creating a quad with a texture to actually render that, and then inside on update we have some very raw logic to recognize if the mouse button is hovered, and then because we don't have an event system yet, that's coming probably in the next video or so, we have this weird kind of logic over here to make sure that we only respond to the first click. And we basically do that by just checking for the release of the mouse button if it has been pressed and we're hovering over the button. And so if that switch button is pressed, we are the overlay layer. We're a completely external layer. So we have to ask the application to find us a void layer if it exists. And you can see we just do that by its type. If you have multiple instances of the same layer on top of each other, this can get problematic. You might have to retain some special instance, or you can go a little bit further with layers by assigning them different IDs. But anyway, for the basic case, this is good enough. And also you typically only have one instance of each layer class anyway. So if we are currently on the void layer, we'll transition to the app layer. If we're not, then it will try and get the app layer and transition back to the void layer. Now, as I mentioned a little bit earlier when we were looking at the diagram, this isn't suspending the layers or anything, it's actually destroying them and recreating them. So if we have a look at this log over here, every time I switch from the void layer back to the app layer, you can see it's actually creating a new app layer. And that message is being printed over here in the constructor. If you did want to keep the layer alive because you don't want to keep recreating it, or you want to keep it in its current state without releasing the memory, then you can of course do that, but you need to keep the layer active somewhere, and you need basically that suspension system that I was talking about. Okay, so hopefully this makes sense. You can see now from the user-facing side what it actually looks like to have all of these different layers which have their own different functionality, logic and rendering, all of that. They can exist over the whole application, or they can be transitioned to other layers. Hopefully now you can see why layers and this architecture are useful, how it helps us keep our code much cleaner and more organized. I mean, really, it lets us avoid stuff like this from a previous code review, where inside our main application loop, we have like this current state that we then need to switch between like menu and game, and then go up here. None of that is required with the layer system because we just have a group of layers currently active and we can transition between them. And because they are typically created and destroyed every time we transition away from them, it means that our state for them resets as well. So if you were transitioning from the main menu to the game or vice versa, you wouldn't need to worry about resetting the game or anything like that, because that's kind of intrinsically already happening since you're destroying the object, all of its resources, all of its associated memory, and then recreating everything from scratch. And again, if you don't want to do that, you can always suspend layers. So now let's have a look at the application class and how all of this is actually implemented and how it works internally. And spoiler alert, it is really simple. So the layer stack at the moment is just a vector of unique pointers. That's it. It's very simple. It's not a stack. I prefer vectors. The memory layout is the same. The iterating through them is basically the same. To me, a vector, a dynamically sized contiguous array of memory, is just simpler and more straightforward to deal with. So that's what I tend to use. So as I kind of showed in the last video, we have our layers being updated by just iterating through that layer stack and being rendered. This system at the moment doesn't have the concept of removing layers from the stack. We can transition layers, but we can't really remove them. And so what transitioning does is it just swaps out the layer that is within the layer stack to be a different unique pointer of what you're trying to transition to. And yes, you can technically transition to yourself. So void layer could transition to void layer. And the effect that would have is it would just destroy itself and recreate another instance of itself, which can be useful. Maybe you want to reset the game state. You can just transition, from the game layer to the game layer. Okay, so if we have a look at what transitioning does, then basically it needs to accept some kind of layer type, of course. You can see over here that it takes in a template argument, which is the type. It will then create a new instance of it along with any arguments the constructor might want to take. And then it will call this QTransition function, which I've called QTransition, but you'll see what happens in a minute. And if we look at that implementation, it starts off with to do, don't do this, which we will explore in a minute. But ultimately, it will just grab the layer stack, look for the exact instance of layer within that stack because it should be there. And then once it finds it, it's taking this unique pointer here by reference. It will reassign that to this layer that we take in over here. So the unique pointer that we created over here, you can see gets moved into the QTransition function and then moved into that layer reference, which is within the layer stack. So we're literally moving that unique pointer into somewhere within that vector, within that layer stack. So that's kind of the simple logic of what needs to happen. Our current layer stack in this example has two layers in it. We have the app layer initially, that's how the application starts, and that overlay layer at index 1 sitting on top of it. That has that switch button. When we transition from the app layer to the void layer, that happens here. So this layer at index 0 on that vector will now contain that void layer that we've transitioned to, and then vice versa when we go back. So this is completely untouched, that's irrelevant. This is what we're playing with, this is what we're switching out. So the rest of the layer stack is completely untouched. When we're transitioning, if we had more layers here as well, then the actual layer that we call transition from, that is the thing that we're modifying. So that's important, of course, because we don't want to completely destroy the rest of our stack that might have important layers in important positions doing important things. We're just trying to work with that one layer changing into something else from within this layer stack. So the elephant in the room, to do, don't do this. Why is this here? Well, at the moment, we are doing this synchronously or immediately. Usually you want to queue this transition, as the function name might imply, to be done later. You essentially want to defer it until the end of the frame, or at least the end of all of these updates happening over here. Why? Well, you have to think about the origin of where this is being called from. So if I put a breakpoint over here and we run this and I press the 1 key to switch to our void layer, you can see that we're trying to transition to our void layer. And where is that happening from? It's happening from app layer on update. Now, when we move a new unique pointer into our old slot inside that vector, thus releasing that unique pointer and destroying it, what's going to happen to our app layer that we are currently in? Well, if we put a breakpoint here and I just hit continue, guess what? It's going to get destroyed. So we're calling the destructor of app layer from this line of code. You can see that over here inside the call stack. That is bad because, again, we're destroying the app layer, but we're actually in a function in that app layer instance. So if we had additional code over here after this transition that maybe set like some member variables or did other logic, that would probably crash our program. And I mean, it would certainly be undefined behavior. Now, of course, you can kind of fix this or be safer about it by returning as soon as you have a transition. It still might seem weird because after this line of code, you're actually in a invalid instance of app layer. But again, this is C++. This is just a function. It doesn't matter if the actual underlying instance is now invalid, as long as you're not using stuff from that memory and you're already inside that function call. So it's technically fine, but it's obviously not a good design, not a safe design at all. So you would typically queue the transition. You can do this in a number of ways. You can have like a post frame function queue that you could just like wrap this in a Lambda, do it there. You could have some kind of layer transition event that then gets triggered with the appropriate data. I'm going to leave this as an exercise to you guys. You always talk about how you love your exercises, so I'm going to make an architecture series channel on my Discord server, and feel free to discuss it there or in the comment section below on YouTube. That works as well. And then next time with the event system, I will coincidentally reveal the solution. Now, as for the other function called getLayer, which just looks for a layer of a particular type, the way this works is it goes through the layer stack and just tries to dynamic cast all of the layer pointers into the requested type. Now, this is not a good way of doing this either, not how I would do it in a more complicated application. It's the simplest way I could come up with without overcomplicating things. However, that's also something that you guys can discuss and I can show you a better solution in a future video as well. But anyway, that's all there is to it. It's like super simple, it's super clean, it lets us avoid having like some switch statement with all these different states or anything like that. It's all kind of handled by layers, and all of our functionality that is specific to certain layers is segregated within that layer. It's contained within that layer, which is both good for just code organization and readability, but also for resources that might only be associated with certain layers. They would get naturally freed when that layer dies, because you're kind of associating the lifetime of this class with those resources that function with that class. It's really quite simple and super clean. Now, next time we will most likely look at the event system. That's also a crucial part of application architecture, I would say. If you guys have been enjoying this series, and please show it some love by hitting that like button below. You can also drop a comment below with your thoughts, and I will see you next time. Goodbye.